Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on stream, and we are doing a little bit of debug code cleanup at the moment. I'm going to go ahead and jump right into it because I don't actually know precisely what we want to clean up today. I mean, for sure, I think we want to try and finish up some of the way we were getting the debug hierarchy in place, but I think we also want to start in on getting our profile view working cleanly. So we got a bunch of stuff to do, so I'm going to go ahead and hop in on that. If you are one of the people who's following along at home with the source code, today's day 251, so do day 250's source code and start with that. That is where I am starting with today. So let's go ahead and open things up here and see where we're at. So let's see. Here is our Handmade PRJ, and we have built it. Let's load the debugger and run it. And at some point, I think we should probably pop back over to the OpenGL thing and remove some of that context creation stuff, because man, it's so long. It takes so long to start up now. It's just really frustrating. But anyway, I think we were sort of almost finished with the debug hierarchy stuff here. And you can kind of see that we have a space for our debug profile here as well, but there's nothing in it. So obviously, you know, that's something we would want to deal with as well. But none of that is neither here nor there. Is this actually is like a solid shaded window? It looks like it's like has a darkening behind it. That's interesting. Anyway. But first we got to finish sort of this stuff up where we want to be able to edit these things and have these things come out in the right places. And we're mostly there, but not quite. So you can kind of see that like we started down here and we're not quite there yet. You can see that the path gets read properly, but then the name of the actual item is not correct at the moment. And also we have not yet enabled the ability to edit these, which we would also like to do. So I don't know if we'll get to doing the profile today, but I definitely would like to try and get it to the point where we can edit these things. So I think there's probably a little code involved in there that might take a little while. So that's what I'd like to try and get done today. And then next week we can just finish up. I think that gives us most of what we want for our debug output. Next week we can try doing a couple things like putting some profiling stuff in there, unless this happens to go really quickly right now, and then we can start on the profile today. Either way. But that's where we're at. So let's take a look here at what we need to do to make that happen. Let's bop over to ForCoder here. So right now, it looks like our main problem is that when we're outputting these debug events, we're obviously printing a name that isn't what we want the name to be. And so we can see here that we've got this event GUID is what we're starting with for the name. And there's a start at // thing, which says like go till you find the last slash, and you know, maybe we're sending that, maybe we're not. But the point is, in order to actually figure out how to display all this stuff, we need to sort of now have some idea of how this hierarchy is being built exactly. We sort of worked through some of that, but we've got to make it actually be totally correct now in order to have the display that we want. So looking through how it's currently getting built. Oops, I gotta get there we go. Looking through how it's currently being built, if you remember correctly, the way that it sort of happens at the moment is debug blocks themselves sort of get moved into the hierarchy as actual elements, and then whenever those debug blocks get output, they output the events inside them. In fact, this is the actual routine right here. You can see when we come to a data block, it gets printed out right here, like so. Now, it seems to me like this is the thing that I don't really know, and just kind of thinking it through. The only reason we wouldn't do it is because we might want to display multiple data blocks that are all the same kind of data block. But it doesn't make a whole lot of sense to me why we actually even need to have data blocks stored in the hierarchy as separate printoutable things like this. Other than the one reason that when we go to draw events like this here, you can kind of see that if we were to have multiple data blocks of the same kind, that would actually work okay at the moment. Whereas if we made them all in the hierarchy, it wouldn't necessarily work correctly. So it depends on how we want to approach that. I don't know necessarily how we want to approach that, but we could sort of simplify this down by saying that data blocks always kind of get expanded into the hierarchy at the time when we see them. They get slots in the hierarchy directly, rather than just having the data block itself have a slot in the hierarchy and then the thing get printed out on demand, which is what's actually happening right now, right? So thinking that through is mainly the part that I was talking about. Now, you can see that when we're printing out these names, you can see us doing the debug draw event business happening here. And when we call debug draw event for each of those things, for some reason we're getting a weird name for each of them. And that's the part that I kind of wanted to look at a little bit. And I know we've got the store event here. And I want to take a look at that. So inside store event, when we produce the actual name, you can kind of see here, we actually take the name that we want to call the element, and we put that into the GUID. Now, the thing about this get name that happens here is that that's going to give us the whole name, including the slashes, right? And so that's actually, you know, when we look back here, it actually makes some sense to me why we're seeing, if OpenGL ever starts up, why we're seeing, you know, renderer/camera as a name of the element. That makes some sense. What doesn't make a whole lot of sense is why the final thing after the slash does not appear to be there, right? That part, much more confusing. Because if we take a look, and I guess maybe we'll go back here, and let me just make sure I understand what we were trying back when we originally created the debug value stack that we were printing in the first place. You can kind of see here, we've got the data block, render camera, and then inside here we've got each of these debug values. Those debug values should have been named like ridiculous stuff. Like we should have seen global renderer camera use debug. Should actually have been what showed up under there. So, you know, that's what I'm expecting to see under there, and that's not even remotely what we actually are seeing under there. It looks instead, you know, what it actually looks like in this case is it looks like the debug values themselves are inheriting just the debug block's actual name, right? So this is the name of the debug block that's getting inserted there. But we don't actually want that at all. Like, we don't want the name of the debug block there. We want this name there. And I'll quickly verify that we're actually passing the right thing down, because obviously if we're passing the wrong thing, that would be why. But presumably we're passing the right thing and just parsing it wrong, because that would seem to be the most consistent with the behavior we're seeing. So you can see here, here's debug value, and you can see record debug event, and we get the debug name here, and then we do the set event, right? This debug name with the pound value, that should give us a debug value that actually has the name global renderer camera use debug that's getting passed down there. And so now I want to go back and look at Handmade debug to see why we're not getting that as the actual name. Like, why are we not seeing that name? Because we shouldn't even be able to get the other name. So it's a little confusing to me, right? So that's what I'm doing right now. So anyway, so here we are in Draw Main Menu, right? This is how we're normally drawing stuff. And when we draw one of these elements, we come through here and we're calling debug draw event, which I should go verify that that's actually what we're calling each time, like that we're actually going through this path that I think we are, and it's not something else that's happening. But if we assume that that's the case, then what we're going to end up here is in debug draw event, we're going to have the stored event that we saved, and that's the thing that we're going to come through here to actually write out. So you can see here, here's debug event to text. We're passing this event here, right there. And you can see that that stored event, we're getting just whatever the event was off of it, which is, you know, just the most recent one for it, presumably. That stored event's the most recent one, and we're just getting the event of that to print it out. And so when we go to print out that event, I feel like what we should be getting is we should be getting that name, right? We should be getting the name there. So, you know, that's what I'm assuming. So there's add name, and when we do add name, that just, we grab the GUID out, right? That's what we looked at before. We grab the GUID out of the event, and we stick that on to the end, right? I mean, there's the usename, and we stick that on there, and then we may or may not add a colon, depending on which one we're printing out, right? And that's it. So I'm not sure, and so I think I'm going to have to step through in the debugger. I'm not sure why we're getting such a strange result from these guys, and I don't know if there's something else weird happening that's like that's not the code path we're following, or if there's some other thing that I'm missing that's that's going to elucidate it. But point being, at the moment, that's why I'm a little confused. So let's go ahead and take a look at what happens when we actually go to loop through this data block. So I'm just going to take a look at what these events actually look like so I can see. And so here is the GUID. So that's actually, I mean, basically the problem is upstream, right? Because we're already getting render/camera here, and we should never see that. Like, that should just never be seen ever. So at this stage. So somebody, when they're actually storing the events, is doing something dumb. And that somebody is obviously me, because I'm the only person who touched this code to the best of my knowledge. But point being, one part of the code is doing something dumb. So I want to take a look at what's actually happening here when we store those events to see if I can ascertain what the actual problem is. So first I'm going to look and see, try to pick an event that's reasonable. So let's take a look. So this is totally fine. Global renderer test weird buffer size. That's totally fine, I think. Because that's, if we go back over to handmade.cpp, you can see that that's this one right here. So we should be able to see why that one isn't getting labeled with its own name. So let's take a look. If you step into store event, here we are. And I guess actually we can't step in now that I think about it. Because what actually happens is that's already been parsed. It's been parsed up here with get element from event. Right? That's actually what's happening as it gets called up through here. And so that's probably the actual problem. Right? Yeah, so in get element from event, it's going to pass that event down. Right? And then that's going to do this funny business here. It's going to take a look at this GUID. It's going to use the current event GUID, whatever it is. It's going to store that. Then it's going to use whatever it parses out, right? If that makes sense. So it's going to do all that, and it's going to do the add element to group, which we don't really want it to do, right? And so this gets back to the thing about these events are not actually stored in there, but they still go through this path for no real reason. And so this is why I say I wonder if these things need to actually be parsed more properly. Because if they're going through one of these open data blocks, we actually, yeah, this just actually needs to be probably a little more clean. Let's actually pull that out so it's easier to debug as well, because we're going to have to deal with it anyway. Eventually. So I'm going to go ahead and do get element from event. I'm going to actually just go ahead and take that out of here entirely. And then I'm going to compile, and then I'm going to go see where that's actually used, and I'm going to make that happen on demand a little more, right? So like this. And that way when we come down here and we're going to do the storage element thing, at least at this point now I can have it do the parsing in a place where we can watch, which is better, right? And I guess what we want to do here is actually say, like, okay, if we were going to store it in some place, if we were going to store it somewhere, we should just use that, which normally we would. Otherwise, fall through to this. So that's a little bit more sane, I think. Whoops, that's not right. All right, and that kind of elucidates why we were having the problem. So what'll happen here is we'll just use this element to store it. It'll get these events will get stored under that storage element, and it will never actually get its name parsed, right? That's the actual problem that's happening there. This event never actually gets processed in the appropriate way. So that's actually, I think, why we're having this problem. Or at least it's a big portion of it, right? So when we actually do that parsing, and we come through here to look at this particular element, we still need to be able to do, this operation. We still want to be able to strip out that whole sort of rest of the part of the name. And so we would want to search for, we would want to do the find last pipe kind of a thing. And we would want to start the name there. So I'm going to hack that in for the moment, but then I think what I kind of think I want to do, again, to sort of start simplifying things, to continue simplifying things more, is I feel like we just want everything to go into that hierarchy so that we don't have this constant problem of, these things go into data blocks, these things don't. I'd rather just have it so that the data block is just a way of grouping things together. If that makes sense? Because I feel like, again, this is a case of like, yeah, there is some reason why we might want to do it this way, but are we really ever going to use that functionality? And if we're never going to use that functionality, then are we just making lives harder for ourselves every time we want to do debug stuff by having it so crazy? Right? Because the debug system, we might want to pop in periodically to add something if we're trying to debug a problem and we want to add something. We don't want it to be like a huge disaster in here all the time. I mean, yes, it's only debug code. We don't have to worry if it's shippable or not because it's not going to run on end users' machines. But we don't want to leave a huge liability for our own selves in case we need to use it, right? So that's kind of where I'm, why I'm thinking about it that way. So if we were going to do this, then what we would want to say is like, oh, okay, so the event, right, that we actually go to store, we need that event to actually skip the pipe part. So we would want to here do something kind of like, let's see, for, I don't know, event GUID scan, if star scan equals pipe, event GUID equals scan plus 1. Something like that. So I don't actually think that's quite the entirety of it there yet, but at least now the event itself is actually moving past the GUID that it was on so that we'll actually have it be stored correctly. So for example, when we come down here to the storage event, there's that event, and now it should just be the name, which it is. So that's at least a good start. Okay. So that's thing one. And now thing two is when we're grabbing these out, we must not be grabbing the event out of the right place somehow. We must be grabbing the wrong actual piece of information when we loop over the open data block. So here, where we do our open data block, where we do start with the last open data block and scan across it, we must, for whatever reason, not be getting the right events out of here. Let me see, store. In fact, you know what happens? It's actually store event that's causing our problem, right? Isn't it? Because if we take a look at that store event, it's probably overwriting the GUID. Yeah, you can see it happening right there. Right, so that's the problem. That's the actual problem. It's taking that element name and we're storing it under this other element, right? And it's sort of forcing it in there, which is not what we actually wanted. You know what I'm saying? So that's pretty much it right there. Yeah. So in fact, this doesn't quite fix the problem because then we still have the problem with the tree elements being wrong, but that's actually what was happening, right? So okay, so yeah, so basically, like, I just think that that's still a little bit too janky in my opinion. So I don't know I don't think we want to keep those open data blocks in there. I think we want to just get rid of the open data blocks and just use the open data blocks. I mean, still put them in the stream, but we just don't need to store them, right? And so I think what we would want to do is leave the store event happening the way that it's happening, but now we're always storing under an element, and then we can sort of restore the way that this process worked to something a little more sane as necessary. And so, for example, the way we would do that, right, is we would say everybody gets an element, so this nonsense never happens anymore. We always allow the element to go into its actual place in the hierarchy, like so, right? But what we need to do is have a way of, well, I probably shouldn't, I guess. Where's my... There we go. So I still want this code in the sense that I still want to know that I'm in an open data block, because I want that data block's element to be my parent, right? But I don't want to do anything else. I just want to basically use whatever it was as my initial parent. That's it. So it's going to be more like debug element initial parent, or like parent, like that. And then we're going to say, like, okay, if it's the first open data block, then the parent is whatever that data block's element was in the tree. And otherwise, it's going to remain 0. Then when we do, well, I guess I got to copy that from here. So I deleted it for no reason. Then when we actually store this guy, what we need to do is call getElementFromEvent, and now we want to be able to pass that parent in. And so you can kind of see up here in getElementFromEvent, right, where we call down through here. And we say, oh, you know, if we didn't find one, we've got to make this element, right? And then we do add element to group, and we do that get hierarchical group from name, and we're passing the root group here. What we want to do instead is we want to be able to actually use the group of that previous debug element, that previous parent, right? And so it'd be like this, right? We'd say get element from event, and we would have like debug variable group here, and this is the parent group, like so. And so when we're actually inserting this thing in here, we would just say like, oh, this is the parent. I guess we would probably also say like, oh, okay, if you don't specify one, you know, if there's no parent, then we'll just default to inserting it into that root group, like so. Now, the problem with that is just that I don't actually know where to get that root group out of here, right? Because, of course, I don't remember. But if we take a look at this thing here, where we get this first open data block, I'm assuming that we have a way, if I go to debug.h, I'm assuming that there's some way there of let's see, where's open data block? I'm assuming that there's some information about what the group actually is. So yeah, like right here, that group right there, that's what I actually want. So rather than storing the element, I don't care about the element, I actually just want that. And this is actually going to be a debug variable group, like so. So that seems like probably more what we want to do. Okay. All right, so, of course, apparently that is not working at all. Probably because if we look here, we don't actually ever update that, right? So we probably just need that to be updated here, and that's probably it, I would assume. Right? Let's take a look. So inside debug element, here's debug element. So we've got our debug element, which and we got our open. What happens during allocate debug block? Yeah, so we never set that group at all, right? And we would want to set that group. When we do get element from event and we get this back, we need to record what that group actually was, is the problem. And at the moment, we're not doing that, right? And we need to find that out. So when we do get element from event, our problem is that we're losing that piece of state. So we come down here, and when we actually do this get group for hierarchical name, and then we do add element to group, when we're adding that debug block, it's getting added as a regular element, which is, not what we actually want. And in fact, now that I think about it, I suppose we don't really ever want to add the debug block as a first-class citizen anyway. So I suppose it's really just going to be this when we do that. So for open debug block, I almost think, I guess we don't ever actually do any of this, right? We don't insert it at all. We strictly do that, right? And so when we call, I guess we just don't even do any of this, right? We literally just do the part where we get the name out of this guy, right? Which would require us to have that parsing pulled out a little bit, but that's really not a problem. So when we do open data block, we would get whatever that hierarchical group name was, and then we would call open. We would open the debug block, and I guess that open debug block, it never would actually have an element here, right? There would actually be no element because we wouldn't ever add the element to the tree because there's nothing to add, and so it would just be 0, right? Then inside the open debug block, I mean, we could create an element if we wanted to. We just don't really have any need to. So inside the debug block there, we would just say like, oh, okay, the group for this debug block is whatever that group was that we insert in here, which I guess we have to actually do like an add group. Let's see, get hierarchical. Is it get group 4? There it is. So we're just going to do get or create group with name, right? Don't know what's going on there. All right. So we know what the parent is. This is the actual name that we're going to use, and that we know as well. So that's pretty easy. I guess this is the size of the name. So it's more like that, right? And so all we need to do here is when we actually parse, we actually need that bit of name parsing that pulls out the information. We need that sort of to be a standalone unit, which is pretty trivial, right? And it's just going to be something like that. Okay, so here's name length, here's name or whatever. Well, actually, I'll just go ahead and pull that stuff out. So that is right here. And what we need is all of this, right? And in fact, we could even keep the hash value in there as well, because why not, right? So we need something like this: debug parse name, debug parse name, and in here we would just pass whatever the name was, and then we would run this thing on it, like so. So pretty straightforward. Yeah. So we just say, all right, there's the result. And now, when we do this scan, instead we're always going to write into the result. Pipe count we don't need to store because that's only used in here. So that can stay. Everything else can happen in here, like so. So now when we do this little doodad, we can just say like, okay, we've got a debug parse name, and that's going to be equal to debug parse name of the event GUID. Now we've got that parse name, and anywhere in here that you used to need to use that, it can just use parse name dot whatever the thing was, and that's all good, right? And I think that's all we really need for that. Let's see. That's got to be GUID again and again. There we go. Hash value, of course, is now in parsed name. And okay, so now we're down here. So now we can do the same thing. And so the event GUID that we get here, we can parse. And now we know everything that we needed to know about it. We could also pull this out, which we might want to do, but that's a separate issue. And so here we can just say, you know, whatever the name was, we can, and in fact, we could actually just include it right in there. So let's do that. Right? So here we've got name length and name, and people can just ignore them if they don't want them. And then we can just say, like, at the end of this, okay, so, you know, the result.namelength and the result.name. The result.name is obviously just wherever the GUID started plus name starts at. And then the name length is just going to be whatever the total length of the string was, right? So scan obviously ends the string. In fact, I guess I got to pull that out here, right? Scan ends the string at this point. It's sitting at the end. So if we were to take scan minus GUID, that's the total length. So that subtracted away, and we subtract away where the name starts at, gives us however long the name was. So that's, you know, that's that. Obviously, we got to tell it that we're never going to have strings that are over 4 billion characters long. Always good to double check. And then we just have to finish up this thing. So, all right, git group. The parent here is just going to be the debug state root group. Actually, that's not true, now that I think about it. Because aren't these things supposed to nest? So technically, it's actually this, right? So I think we actually want to do something more like this. You know what I'm saying? Because that way we'd say, oh, debug state root group. That's the default parent group. And I think we want them both to go in there, right? So we would want this to go into the default parent group. And we would want this to do the same, right? I mean, that's... right? Let's see here. Default. Element. Store event element. No. I don't want to store anything there. Don't store. Do not store. Does not store. Do not store. All right. So now everything should be getting stored in the hierarchy. Of course, I may have messed something up. And in fact, I specifically did mess something up, as it turns out. Where's this getting called from? Wait, what are you doing calling call from here? Okay, that's storing the closed data block. Why are you storing the closed data block? Nobody asked you to do that either. Of course, I want to know why it doesn't work, but I don't actually want you to do that, for the record. Let me take a look at the element. The element is null, which would be y. So I don't know what's wrong with that. First open data block is here. Oh, because we don't store that. Yeah, right. We actually removed that. That's totally valid. It's gone now, so that can't happen. So that's fine. Don't care. That goes away. Oh, OpenGL. All right, so getting there. Almost there, but you'll notice we have a weirdness here with this whole situation. And I actually think that may actually be a data bug. Now that I think about it, actually. That may actually be us being stupid. So in here, this is not right. I mean, that's why that happened. Yeah, where was the other ones? Platform. So that's in Win32, Handmade.cpp. Platform controls or platform/controls. So that's, well, that should work. So that's a screw up. So we should go fix that. But render camera is right now. Okay. So let's go ahead and flip back here. And we should now be at the point where we only have the ones that don't expand out like they should, right? And let's go ahead and double check here that this part works, where we can actually look at the simulation entity, and we can. Although why we can't view bitmaps in here, I don't know. So I have to take a look at that too. It's kind of nice to be able to view debug stuff, right? Like there's our velocity, right? X, there's the velocity in Y, right? Facing direction. There's me jumping. Don't know why jump is still enabled. This game is not supposed to let you jump. Probably should remove that. We'll get to that soon. I guess we'll start doing gameplay coding pretty soon, so I'll get to go through and clean all that code out. All right, so that's good. But again, not pleased with this. This is not working properly. So when we do our name parsing here, and we do get group for hierarchical name, I don't understand why it's not creating two links down, why it's not doubly expanding. So that's a little weird. I guess the reason is because when we do that get group for hierarchical name, we don't then remove the slashes, right, from this thing. So that actually is probably why, now that I think about it. We would need to go find the last slash in the name at that point and move the pointer forward to it. But just to double check, that's not quite correct, right? No, it is correct. No, it's correct. All right. So when we do get group for hierarchical name, what I think I actually want to do here is just make a slight modification to that function. So if I go up to get group for hierarchical name, and we look at how that's working, where is that? Get group for. So if I'm in get group for hierarchical name, what I want to do here is say like, oh, okay, instead of saying if first separator, I want to kind of always do this, actually. if that makes sense. So I want to do something where I say like, oh, okay, it's really that I want to always create that all the way down the tree. I just don't want to continue going hierarchically if there were no more separators. And so this can be if first separator or create entire tree or something, or create terminal, right? And then so when we call this, we can just say, oh, create terminal. And then that way, it's easier for us to do. So yeah. So when we do this, and we're creating an element, normally we don't want to do that, but when we're creating one of these guys, we do want to do that. And then we don't really do a parent group anymore. It's not a parent group, it's actually the group, I believe. And so then when we set the group, we don't actually do that, right? So then we just let that function do what it's doing, and then it'll automatically strip off that slash for us, I believe. Or we could crash the program. Because, well, it's not. I guess we're not crashing the program. We could get an assertion, which would be always fine. Everyone loves an assertion. So what happened there? Oops. Go back. So yeah, when we create the debug block here, I'm going to rearrange this code a little bit. When I create the debug block, oops. That presumably should not have changed anything. So I believe the only thing that we're looking at here is really going to be that change I made to get group for hierarchical name. And so for that, why? I wonder what's happening there. When we get or create the first separator minus name, so that's the problem right there, right? The length computation is going to be wrong. So what we want to do there is essentially say, okay, first separator is 0 when we come out of here. So really what we want to do is say when we come in here, if we don't have that, if the first separator was not set, it's just going to point to the beginning of the string, right? Because that way we would create the full name at that point. Or I should say the end of the string, right? So it's basically like scan is going to be first separator. I don't know if that makes any sense. Like this. There we go. What? All right, so I admit that that was not brilliant. That was not great because, of course, since we also use that to do the recursive check, you know, yeah, that's going to go on forever, right? Just straight on forever. So I think we actually want this. Probably makes more sense. So, in the case where we do have a first separator, then we can just use the name length that we were using before. But in the case where we don't, then we can use the name length that we were computing the other way. So that's just the same exact thing, but it's the whole string. Not quite. Subgroup is still getting... What gets returned here? result equals get this should actually be result here as well. We want to take whichever result, like if we created a group, we want that to be the result, period, right? So that's what we actually wanted, because we always need to return something, otherwise the group won't have anything in it. So I think we're good. That looks like everything that I wanted, right? So everybody's there. And so now I don't really remember, I mean, that's obviously all working properly, but I don't really remember why we don't have editing for these guys, because I thought we did have editing for those guys, at least at one point. So I'm not sure why those debug values aren't getting edited, are not able to be edited, if that makes sense. I also think that now our open debug block stuff can get yanked out of here. So let's just get rid of that. Where's that at? No! No, don't do it. No. I can't. I didn't want to stop programming right now. Can't you see, Mr. 5-minute warning, that I'm right in the middle of something? What is wrong with you? So yeah, so this stuff can go away. And here in this code, I think, can just get vaped, right? That can just go away. Goodbye. And I think that's all there is to it. So that's good. So now let's also take a look. Why can we not edit these things? So when we come through here and we create one of these guys, right? We say default interaction for this thing, but we're not actually getting any interaction. And so I don't know why. Like, is there a reason why auto modify variable is not actually doing anything for this type? I mean, it should be a B32, right? So it should be setting it to toggle value, I would think. But that is apparently not the case. You know what I'm saying? So for some reason, auto modify variable is refusing to modify these variables. Is that, why is that? I ask you. What is the problem? Here is a B32. I believe these things are B32s. But maybe they're not. Right? It could just be coming through as an S32 because that's what it would crack the type to. Let me take a quick look. Oh wait, I'm in the right file already. So when we do debug set event value, you can see here, yeah, it's never going to set it because it doesn't know that it's a Boolean, right? It doesn't know that it's a Boolean. So what we really need here is a way to clue it in because it's not a real type, right? Because C++ is awesome and always does everything wrong. So what we have to do is we have to tell it manually that we wanted this thing to be a Boolean, right? That's what we actually needed to do. So if we do it like this, where we say like, okay, set the value to be the value and set the debug type to be a B32, then I think we would actually get it set to the proper value, right? I think. And so now if I went in here to handmade.cpp and said, oh, like this is a bool, right? I could just say debug bool or debug b32. on these, right? And that would be debug. What is the problem? Oh, because this is actually value b32. That's the problem. And that's not what that is. Not a b32. All right. So that presumably would do something resembling anything. So let's see if that made those values editable already. That's like use debug camera was one of them, for example. Let's see, camera, nope. No, that is one. So it's showing up as a B32 now, but I can't click on it. So what's the deal there? Like, what's going on? I wanna know, Mr. Debugger, I want to know why we can't do that, because that's like, I guess our next thing is to go through that system and start cleaning that up a little bit as well. But I feel like that should have gone to a toggle value. Maybe we disabled toggle values, but like debug interaction toggle value, there it is. That set the hot interaction to a toggle value. So I just watched it happen, right? So what's the deal? Not really sure. So I'm assuming, well, I guess I know why it wouldn't actually toggle. I just don't know why it wouldn't highlight. The reason it wouldn't actually toggle is because we don't have any way to re-pick up those changes. So for example, if we go back in here into debug b32 or into debug value, either or, when we go set this stuff up, we don't actually try at this point to go get any changes to that particular value, right? So we don't try, we make no attempt at picking up a change that might have occurred with that value. So what we would need to do here, in this particular case, is we would need to say like, oh, okay, if there is a changed value, like we'd need to do something here where we do like if, you know, well, I guess it'd just be like this. It'd be something like this, where we'd say like, okay, this thing, if you wanted to overwrite it, go ahead and overwrite it now, right? And it would go pick up that change as necessary and write over the value with a new value if there was an edit that had been pending. So, you know, when we do that edit, it has to edit the value in the element, and then it has to sort of store that value back. I don't want to try and do that right now because I don't think that's, well, that's not going to be very helpful in like 5 minutes or whatever I've got left. So we'll do that next week. But that's why we don't get edits. But I feel like there's also a problem because it should be highlighting that line. And since it's not highlighting that line, I think we maybe also our IDs are, it's because maybe we haven't done the debug ID stuff properly for these things yet either. So I guess we still have a fair ways to go on like cleaning this up entirely because we have to clean all of that stuff up. Because none of it's really correct at this point. And so we're only just getting the hierarchy into shape, but we don't actually have the other part in shape yet. So yeah, but I think that's what we actually would want to do. So I'm going to save that for next week, and that'll be that. Oops, what did I do? I don't know what's going on here. All right. So yeah. But I think that's mostly all we actually need to do, is just do that and then we would be good to go. That's my suspicion. And this, of course, has to pass the event as well. So it basically just looked like that. And the same would be true up here. But I guess I probably shouldn't insert those in the middle of a macro. Unadvisable. That'll be good. All right. Let's go to the Q&A. Do you know 27/1988? Wednesday you talked about Microsoft's Xbox process to detect which vertex was close to another to form quads, tris, faces. I definitely didn't say that. You have the math behind that, or maybe a link about it. I tried looking for it since then without any success. Let me try to say this maybe a little clearer. So what I was talking about is the fact that when you pass down meshes, right? This is, imagine like a patch that looks like this. So these are all triangles. Okay. So nobody is, the Xbox, original Xbox had, there's nothing about detecting vertices or anything like that. What I was saying is that when I'm saying locality, what I'm talking about is actually like in a cache, like meaning the actual memory, the actual slots of something. It has nothing to do with where the vertices are in space, right? So just so we're clear on that. So if we have a mesh, here are the vertices and here are the triangles of my mesh, okay? Now, I need to send this down to the graphics card, right? If I were to send this down as simply a list of actual vertex data, right? So the positions of the vertex data, right? Then I'm going to send, even if I tri-stripped it. So tri-strip is when you just send like this, right? And it basically draws the quads automatically. So you don't even have to specify the triangles. It just kind of constructs them as a strip. If I was going to send that, right? And I sent P0, P1, P2, P3, P4, P5. If I send that down as a list, I'm going to send this, right? And these are actual vertex data. So this is actually going to be, 24 bytes, right? Or 32 bytes or something, right? These are big. It's not one integer or one 16-bit. It's not one 16-bit value that's an index into something. It's actually all the data. But that's fine. It can still share because since we told it it's a triangle strip, it knows that the pattern we're sending is this, then this, then this, then this, then this, then this. So it knows it can reuse the vertices to draw two triangles that share two vertices each. And every time we add a new vertex, we draw a triangle. So we're essentially, every time we write one, right? We start out with 2, we don't draw anything yet, we start with 2. But then every time after the first 2, we're drawing a new triangle every time. Because it always knows how to use 2 previous vertices from this stream to draw the new triangle. So we do P2, and it immediately knows that it can draw this triangle, because it knows P0 and P1. We draw P3, and now it knows it can draw this triangle, because it knows to reuse P0 and P2, right? Then we draw this guy, P4, up here, and it knows it can redraw this. We draw P5 down here, and we know it can draw this, right? Of course, now that I realize the way I wrote this, P0, P1, P2, it's actually would be this way. Sorry about that. I drew that upside down. Yeah, if your tri-strip was in this order, then you would not, that would not be correct. So pay no attention to that. Pretend that didn't happen. Let's try that one more time. Pay no attention. So if you were specifying them in this order, P0, P1, right? Then P2 would be here, P3 would be here. It would draw that triangle first, right? And then it would draw this triangle. But it always reuses two triangles from the previous one. So then here again, when I'm to draw P4 here, it still now again knows how to draw a whole triangle with only one vertex. So the way to think about this, the way to think about tri-strips, is that every new vertex draws a triangle, so you are pretty much, except for those first two, if you can just keep the stream going, you have maximal amounts of triangles to vertices, if that makes sense, right? Because every time you specify a vertex, you draw a new triangle. Hopefully that makes some sense. But there's a catch. And the catch is that if you were going to start touching previous vertices that are not the last two that you looked at, if you're only sending down vertex data, there is no way to share these anymore. So for example, suppose I were to draw my tri-strip like this, right? Here's my tri-strip. So I come in here, I draw this, 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 that, right? So I did like, okay, draw this, then this, then this, then that. So it's going to draw that triangle first, then this triangle, right? Does that make sense? So this, 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 right? And now I try to turn this corner, right? So I've drawn, this. I draw this now, or something. So I draw there, right? Something like this. I guess I can't quite draw there. I got to draw here, right? Something like this. And then I try to draw like out here to start going this way, right? If I want to, sorry, I'm not drawing a very good pattern to show this. There's a pattern I figured out a long time ago that actually does this, and I want to see if I can re-figure it out again. I've never actually seen anyone talk about this pattern before, so I might as well try to figure it out again. I think it's like this. So it's here to here, here to here, right? Here to here. So now the next thing that gets drawn, it's got to turn the corner, and I don't remember how you do it. It's this way. The next one that you draw is going to draw across the diagonal. So maybe you go out further that way. So you go like this. I don't really remember. Right? Then you go here to here. That won't help you. So it's got to be the other way around. Sorry, just give me a second. Just give me a second. So you draw here to here, right? And so that's that way. Then you draw here to here. So that's that way. And so then you would draw I cannot figure out what this actually was. Maybe you do it start the other direction. So if I go down, if I'm there to there, and then I do here to here, right? So it's there, 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 so it's that way, right? And then I do these two again, so it'd be that way. I guess actually I want to put this guy a little bit further in. So it's that way. And then the last guy, maybe it's like that. Is this correct? Right? And so this guy would be here, 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 and there. Now, because it's going to connect to this one. So you need that one to be on the interior somehow. I don't know how I did this. It was the weirdest pattern ever, and it was super hard to remember, as you can see. So here. Now what's the next one? Is it... This is going to drive me insane if I can't remember it. And insofar as the interesting thing about this one is there were no degenerate triangles. It's a way to draw a patch that looks roughly like this. And it looks roughly like that, and that doesn't actually ever require a restart. It's just a full tri-strip, and it touches itself maximally, so to speak. I think I used the default ordering of a tri-strip, so I know that it would have been the way that they normally would have encoded it. And so A, B, C, D, E, F. So it was going upward, for starters. So it's doing like A, B, C, D, E, F, E, F, G, H. Yeah, that's it. That's it right there. I, J, K, L. That's it. So you see how that works? So you do A, B, C, that draws this. Then you do D, which draws that. Then you do E, which draws this. Then you draw F, which draws that, right? Then you draw G, which draws this. Then you do H, which draws that. Then you drew I, which draws this. Then you draw J, which draws that. K, which draws this. L, which draws that. Yeah. Again, never seen anyone mention this before. On the Xbox, I worked it out on the original Xbox because it was the way you could make a perfect patch that would get maximum throughput through the vertex cache without ever having to restart the tri-strip. So you never lost an index, if that makes sense. All right. Point being, that was an extremely lengthy way to get to this part right here, which is what I was trying to say. So, if you look at the series of vertices that come down here, it's, you know, A, B, C, D, E, F, G, H, I. Now, I, as you can see, is in the exact same place as E. So if I was sending these as vertex data, I'm going to have to go through and reshade, do the whole transform pipeline, everything, on two identical vertices, E and I, right? And that's stupid, because they're in the exact same place. They're coincident. So what I really wanted to do is tell the graphics card, hey, all you need to do is use where you previously computed that vertex to be. So the reason that you send down index buffers, what I was trying to talk about the other day, is because if you're actually sending these down as indices instead of the actual vertex data, then this stream looks like 0, 1, 2, 3, 4, 5, 6, 7, 4. And the card can see that the indices are both 4. It can have a little cache that it looks into. When it sees 4, do I have vertex 4 already transformed? Yes, use it, right? Now the size, this is called the primitive assembly cache. This is the one that that does the try strip part. So the fact that I do 0, 1, 2, and that does a triangle, then 3 also does a triangle, that's called hitting the primitive assembly cache. And that's the thing that does the like store the last 2 vertices that I used, and it moves things around in that little tiny cache of just like 3 vertices or whatever. That's, you know, so this is like 3 vertices long. It's super tiny. It's only for assembling the actual primitives, right? Like try strips. This part is the vertex transform cache. Oops. And this is the thing which basically says, oh, I'm going to remember some number of vertices tagged with whatever their index was. So like, oh, I know that vertex 16 or whatever, right? I have that. You know, I have what it was transformed as. So if I see index 16, I'm just going to pull it out of the cache, right? So that is how like the Xbox hardware used to work. Does that make sense? And so the reason I was mentioning that was I was saying like, I was using the Xbox as an example of how indices versus vertex data will affect how the hardware actually performs on your stream. It's not equivalent. Even if you take bandwidth out of the equation, if you're not even talking about the fact that the indices end up being a smaller way, indices plus only unique vertices, like unique vertices plus indices, as opposed to just duplicating the vertices anytime you use them again, it actually turns out to be more efficient in a number of ways potentially, depending on how the hardware works. And so just what I wanted to kind of get across with that is that like, hey, if you actually care about maximum throughput on some of these things, you have to actually know what the GPU is going to do. You can't just, you know, assume something about it, because there may be all sorts of caches in there or optimizations that are happening, and if you don't understand that, you're not going to pick the right format for your data, right? If you don't care about maximum throughput, you don't care about any of this, right? And so like with something like Handmade Hero, we just don't have hardly any vertex throughput or transform needs at all, right? That's just not an issue at all. We don't even have anything we're ever probably going to do with vertex shaders. We'll probably do some things with fragment shaders, but we have no need for any heavyweight vertex operations right now, and possibly ever. So this sort of stuff doesn't matter at all for Handmade Hero. But somebody in the Q&A asked the question about this, and so I was trying to be clear in the answer. So hopefully that makes some sense. And so Dino 271988 had a follow-up question there, which is, how does it know which triangles to draw? So this is a part that we didn't talk about in Handmade Hero because, again, it's not relevant. But basically what happens is there's this notion of, like I said, primitive assembly. Primitive obviously meaning the individual primitives, like the triangle or quad or point or whatever is the unit that's actually being rasterized. Assembly meaning, how do I pull together the vertex data that I need to actually do that. So in this primitive assembly, what happens is when you go to draw your mesh, you tell it what kind you're drawing. And we actually did this in Handmade Hero. It's just we didn't really talk about it much because it's not relevant in Handmade Hero. So what happened in Handmade Hero, it's not here, in GL, in Handmade Hero, there we go. In Handmade Hero, we said GL begin GL triangles, right? That is an example of setting what type of primitive assembly you are trying to do, okay? And I'll talk about that in 1 second. So primitive assembly is like, how does the vertex stream sort of indicate what primitives should actually occur, right? And there's a couple of different kinds for triangles. One is actually just triangles. That's the kind we use on Handmade Hero. One is tri-strips, and one is tri-fans. Okay? And what these are is these are rules for interpreting the vertices that come in as to how they will appear in the output. So with triangles, the rule is that vertices are taken 3 at a time to form triangles, period. So if I send down vertex, and in fact, let me just make an example of this so that you can actually see it. Okay. So let's say that I'm going to send down the following vertices. 1, 2, 3, 4, 5, 6. Okay? That's what we're sending down. If I was to say triangles, if that's what I set the primitive assembly to, it's going to take these 3 at a time. So this list, it's going to take these 3 and form a triangle, and these 3 and form a triangle. So what I will get in the output is I will get this, right? And I will get this. That is what I will see. So there's no mystery, there's no knowing magically how it's going to do. It literally is just looking at the indices in the way that you told it. You said triangles, that means vertices taken 3 at a time. Okay, that's triangles. Try strips has a different rule. Try strips is start with the first 2, right? And then the third one implies the first triangle almost exactly the way that you would imagine it would if you were just drawing triangles, right? So I draw 1, 2, 3. Then the rule is for every vertex thereafter, right, or actually including this one, when I draw this vertex, what I want you to do is I want you to permute the previous vertices you were using, such that you throw away the oldest one, right? So I get rid of 1. That's gone now. So it's like a sliding, imagine a sliding window. It started here. So I'm going to move the sliding window down, right? I have 2 and 3. And then I'm going to add the next new vertex in, okay? So now I'm going to draw one that's between 2, 3, and 4, right? Then the next one I do, I slide the window down again, and now I'm going to do one that's 3, 4, and 5, right? So instead of just taking them 3 at a time, I'm now just using every possible set of 3. I'm just moving down by 1 each time. So instead of only using 3 unique vertices, 3 more unique vertices, 3 more unique vertices, I'm reusing every vertex in every, in 3 times, right? The next one is try fan, or I should say the last one is try fan. And what that is almost the same, only that uses a sliding window of 2 and never gets rid of the original. So what that does, it starts with 1 and it says, I'm going to just keep 1 in the entire time, and then I'm using a sliding window of 2 that slides downward, right, 1 at a time. So I'm going to draw a triangle that's 1, 2, and 3, so it draws this triangle. Then I'm going to use a triangle that's 1, 3, and 4, so it draws this triangle, right, one that we've never drawn before. Then I'm going to use one that draws 1, 4, and 5, right? And that's going to be this triangle, this giant triangle here. Then I'm going to use 1, 5, 6, right? Which is this long triangle here. And you might ask, what on earth is that mess good for? Well, exactly what it sounds like. If I wanted to draw something that looked like a circle, let's say, I could send down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, right? Then it would just go, oh, 1, 2, 3, 1, 3, 4, 1, 4, 5, 1, 5, 6, 1, 6, 7, 1, 7, 1, 7, 8, 1, 8, 9, 1, 9, 10, 1, 10, 11, 1, 11, 12, 1, 13, 1, 12, 13, 1, 13, 14, 1, 14, 2. Right? Well, I'd have to send 2 again. So I'd have to send this one more time if I wanted to close it. Right? So that's what triangle fans are for. And you can see why it's called triangle fan. It's like a fan of triangles that fan out around a point. Not particularly commonly used. Tri-strips are very commonly used. So that's what that is, if that makes any sense. All right, so I lost the Q colons here. I don't know where we are. I don't know where we're at. I don't know where we're at. I should have paused my scroll. I don't know. I don't remember where I was in the scroll. Let's see if there's any more questions here. You mentioned shortly to make Handmade startup quicker, which is slow now because of what OpenGL has to do. How would would think we need to load textures first before showing Handmade here? No, so texture load is not what's slowing us down because our textures are loaded on demand. So what's actually slowing us down is just creating the OpenGL context. It's just AMD's initialization routine that's that slow. But we're creating 2 contexts right now, one for texture download and one not, and one we're actually 3. 2 for texture downloading and 1 regular. And since I think we've basically determined that the multiple context doesn't help you because it doesn't actually help on NVIDIA cards as they had suggested it would, we can get rid of those and just create 1 context, which should make us roughly 3 times faster. So that's all. I was just saying, like, we go back there, get rid of those contexts, and then we'd be 3 times faster. We'll still be a little slow because they just take a really long time to create that context. I wish they didn't. NVIDIA drivers don't have that problem. NVIDIA drivers start immediately, but AMD's take forever for whatever reason. For people who do 3D meshes, it seems there's a rule, or at least for Blender, that using anything else than quads for topology produces rendering artifacts, so it has to be avoided. Is this because when rendering in game, everything gets split again into triangles? Ignore the question if what I'm asking doesn't make sense. Yeah, so what you're asking is a little bit of it's a very deep question that actually has absolutely nothing to do with rendering at all. It has to do with it has to do with topology and the way in which I'm not even sure how to begin answering this question. It has to do with topology and the way in which essentially like 2-dimensional manifolds wrap around three-dimensional objects. And if you want to do stuff that has to do with like smooth curves like subdivision surfaces or smooth mappings like texture mappings, then what happens if you don't have quads is you end up with unavoidable singularities or unavoidable artifacts that are like mathematically unavoidable. Like there's nothing you could really do about them. And it really has nothing to do with rendering. The card the graphics card just needs things broken up into triangles with information at the edges, at the vertices of the triangles, and it can render anything that's of that form. But when you start to want to do more advanced things with them, the need to have things be locally planar and non-collapsing is actually very important for a number of other mathematical reasons. And so, you know, that's something we'd go into probably in a lot of depth if this were about 3D programming, but we're not going to get anywhere close to that on Handmade here because it's so not even remotely relevant to what we're doing, if that makes sense. Ginger Bill, with OpenGL context creation, which bit is the slow bit? Is it set pixel format, as it may be Visual Studio 2013 that is the problem? In Visual Studio 2015, this is not 2015 is not as slow. It could be that weird thing that they do where Visual Studio tracks the memory allocations, and that's a good point, Ginger Bill, actually, because we have not disabled that, and we haven't disabled that because we don't go through any of that stuff. So if we disabled that heap thing, it might make a difference. Let's find out. So if we run, you can see us taking a huge amount of time here, right? And all of that's in the context creation. It's in wiggle create context, not in set pixel format. So if we were to disable the debug heap, and I don't know if you can do that in here, but we can do it external to here anyway. Let's find out. How do I disable the debug heap? That may be the problem. It may be that their driver's just doing hundreds of thousands of allocations, wouldn't surprise me, and that those are all getting slowed down because they're going through the debug heap. So let's find out. Visual Studio. Thank you for mentioning that, Ginger. I never would have thought of that, but I just realized, yeah, we've never disabled the debug heap on this machine. I normally do disable the debug heap, but I don't think I ever did here. Disable debug heap. And if that was the case, then that would help a lot. Where is it? here we go. Let's see. It is in Advanced System Settings, Environment Variables, and then we can set underscore no debug heap equals 1. Okay, let's give that a shot. So actually, let's give it a shot for realsies. Let's go ahead and put it in here into misc shell.bat, and let's go ahead and just straight up set that. So set no debug heap equals 1, and save that. So there we go. Close that out. Close this out. Close that out. And see what happens if we go back in. So all right. So no debug heap equals 1, which is what we want. We launch msdev, which will inherit our environment variables here, and we run. Well, it's probably a little faster. It's definitely faster, but it's not as fast as I might have liked. Let's see what happens if we start without debugging. So that's going to be in, where is that? Where's this run? I just want run. Do we have a run here somewhere, people? Project, just run? Hello? Isn't it like Shift F5? Well, it used to be. I guess it's not anymore. There must be some way to start it without debugging. There always was in the past. I guess I never really do that anymore, but... Oh, there it is. It's right there. Control F5. All right, let's try Control F5. I think that's as fast as it's going to get, unfortunately. That's still kind of slow. But, like I said, we can get rid of that... we can get rid of the extra context creation. That may help, right? But I think that may have helped a little, because it was much... I feel like it was much slower than that before. I feel like that did give us a little bit of a boost. Soy sauce kid, is the fixed function GL stuff still viable? I want to do a grid shader, but the examples I'm finding are for GLSL3. I'm using GLSL1 on a Raspberry Pi. Ooh. Yeah, GLSL1's pretty old. And the fixed function GL stuff is, you really wouldn't, like, even we probably won't end up using that in Handmade Hero. I mean, we might still use GL Vertex because we don't really probably need anything there. But yeah. Oh, that wasn't a question. Okay, never mind. Sorry. Never mind. So yeah, just in case anyone was wondering what that was, Visual Studio has this debug heap stuff that it enables, and what happens is if the code that's running under Visual Studio has a bunch of lots and lots and lots and lots and lots and lots of calls of malloc, which C++ happy code tends to do, yeah, it ends up slowing it down tremendously. So I tried turning that off. But it looks like the AMD code's still pretty slow either way. Now, like I said, I think we'll still be able to do something about that by not creating those extra debug contexts. So we can try that and see. But it just, like our startup time was just a lot faster before, so before we switched to the OpenGL context creation. So I'd like to get some of that back. All right, that's about it for today. I'm gonna close down. All right, thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along with the series at home, you can always pre-order the game on handmadehero.org, and it comes with the source code so you can follow along at home. We also have a forum site you can go to ask questions. We have a Patreon page you can go to if you'd like to support the video series, and we have a tweetbot you can look at if you would like to know what the schedule is. And speaking of the schedule, we are going to be back here next week. I don't know what the schedule for the week will be, but that tweetbot is the right place to go to find out. Until then, I guess what I would say is if you're looking for more Handmade Hero, Handmade After Dark, which is FUCon on the tweet on the streams, sort of chat show, which has people from Handmade Hero, will be live tomorrow at 5 p.m. Eastern Time, which is going to be 2 p.m. Pacific Daylight Time tomorrow. And I will be on the show, as well as he and Chronal Dragon, and also Strange Zach, who I don't know was on the stream today, but sometimes he is. So, if you would like to see that, you can check out Handmade After Dark. It looks like Insobot is tweeting that link for you as well. And so I'll be there tomorrow. Hope to see you guys there. Until then, take it easy, have fun programming, and I will see you guys on the internet.